In the previous episode, we learned why Kubernetes exists. Now it's time to understand how Kubernetes actually works internally. In this video, we'll explore the main Kubernetes components: the control plane, worker nodes, pods, the API server, the scheduler, and how everything works together to orchestrate containers automatically at scale. Let's break down the architecture step by step. At a high level, a Kubernetes cluster is organized into 4 main layers. At the top, we have the users. These are developers, DevOps engineers, and applications interacting with the cluster. Then, we have the control plane. This is the brain of Kubernetes. It makes decisions and manages the entire cluster. Below that, we have the worker nodes. These are the servers where applications actually run. And finally, inside those nodes, we have pods and containers, which are the smallest deployable units in Kubernetes. So the flow looks like this. Users interact with the control plane manages the worker nodes, and the worker nodes run the pods and containers. The control plane is basically the brain of Kubernetes. It's responsible for making decisions and managing the entire cluster automatically. Inside the control plane, we have several core components. First, the API server. This is the main entry point of Kubernetes. Every request goes through the API server. Then we have the scheduler. Its job is to decide where pods should run based on available resources. Next is the controller manager. It constantly monitors the cluster and makes sure the desired state is maintained. And finally, etcd. This is the database of Kubernetes. It stores the cluster configuration and state information. So the workflow usually looks like this. A user sends a request using kubectl. The API server receives it. The scheduler decides where the pod should run, and Kubernetes deploys the workload automatically. While the control plane makes decisions, the worker nodes are the machines that actually run your applications. You can think of worker nodes as the execution layer of Kubernetes. Inside each node, we have several important components. First, the kubelet. The kubelet communicates with the control plane and makes sure containers are running correctly. Then we have the container runtime, like Docker or Containered, which is responsible for running the containers themselves. And we also have kube-proxy, which handles networking and communication between services and pods. At the bottom, you can see the actual applications running inside the nodes. So in simple terms, the control plane manages the cluster and the worker nodes execute the workloads. Pods are the smallest deployable units in Kubernetes. In simple terms, a pod is where your containers run. Usually a pod contains one main application container, but it can also include additional containers, like sidecars for logging, monitoring, or security. Pods also have their own networking and internal communication. Here you can see the application container, resource allocation like CPU and memory, scaling replicas, and communication between pods. And when Kubernetes needs more capacity, it can automatically create additional pod replicas. So instead of managing individual containers directly, Kubernetes manages pods as the core execution unit of the cluster. Now let's put everything together and see how Kubernetes actually works step by step. The process usually starts with the developer. The developer creates the application and deployment configuration. Then, using kubectl, the request is sent to the Kubernetes cluster. The API server receives and validates that request. After that, the scheduler decides which worker node should run the pod. The selected worker node then executes the workload. And finally, the application starts running inside a pod. So even though Kubernetes may look complex internally, the overall workflow is very organized and automated. Kubernetes continuously manages this entire process automatically behind the scenes. One of the most important Kubernetes features is automatic recovery, also known as self-healing. Here's what happens step by step. First, a pod crashes because of an application error or infrastructure issue. Kubernetes continuously monitors the cluster using health checks and status monitoring. As soon as Kubernetes detects that the pod failed, it automatically starts the recovery process. Then, Kubernetes recreates a new healthy pod automatically without requiring manual intervention. And finally, the service becomes available again. This is one of the reasons Kubernetes is so powerful in production environments. Instead of engineers manually restarting applications, Kubernetes recovers failures automatically. Another powerful Kubernetes capability is automatic scaling. Applications don't always receive the same amount of traffic. Sometimes traffic is low, but suddenly thousands of users can start sending requests at the same time. Here you can see traffic increasing over time. As demand grows, Kubernetes automatically creates more pod replicas to handle the workload. This process is called horizontal scaling. Instead of running only one pod, Kubernetes can dynamically scale the application to multiple replicas automatically. And when traffic decreases, Kubernetes can reduce resources again to optimize infrastructure usage. This helps applications remain available, performant, and scalable under heavy traffic. So let's summarize the Kubernetes architecture at a high level. The control plane is the brain of the cluster. It contains components like the API server, scheduler, controller manager, and etcd. These components make decisions and manage the entire Kubernetes environment. Then we have the worker nodes. This is where applications actually run. Inside the worker nodes, Kubernetes manages pods, containers, networking, and communication between services. And together, all these components allow Kubernetes to automate container orchestration at scale. That means Kubernetes can deploy applications, recover from failures, scale automatically, and manage infrastructure efficiently. As Kubernetes environments become more advanced, applications start using additional Kubernetes components beyond pods and nodes. For example, Ingress is used to expose applications to external traffic. Services allow pods to communicate internally inside the cluster. ConfigMaps help manage application configuration, like environment variables and application settings. Secrets are used to securely store sensitive information, such as passwords, API keys, and tokens. And persistent volumes provide durable storage for applications and databases. Together, these components help Kubernetes run real production workloads reliably and at scale. And don't worry, we'll explore each one of these components step by step in the upcoming episodes. At this point, you already understand the high-level structure of a Kubernetes cluster. And now, it's time to move from theory into practice. In the next episode, we'll install Kubernetes locally and create our first real Kubernetes environment using tools like Minikube, Kind, kubectl, and Docker Desktop. If you enjoyed the video, don't forget to like, subscribe, and follow the series as we continue building real Kubernetes knowledge step by step.